Welcome back to our discussion about fire-rated gypsum shaft walls. If you're responsible for verifying the installation of fire stop at head-of-wall shaft joints, this video series will help you evaluate the critical elements that are important to the performance of the life safety systems related to this type of construction. Hopefully, you've already watched the earlier videos where we discussed how fire-rated shaft walls are tested and how they should be built properly. After those videos, you'll understand the importance of that rated wall assembly, but the integrity of that wall is just as important as how that wall connects to the fire-rated floor above it. This video and the next few will outline how you can be sure that the connections between the rated wall and the rated floor maintain the code-required continuity. Obviously, that comes from how you connect the two with a system that's tested to ASTM E1966 or UL 2079. We talked about how rated shaft wall is built, we talked about how it's tested, but we didn't talk about how the joints are tested. Well, it's very much the same. They build the two assemblies that are to be connected with our rated joint. They give them time to cure. Then they install the fire stop solution. They allow that time to cure, and they put it on the furnace and burn it to the same basic requirements. If the wall is not the same on both sides, they'll have to test it with each side against the fire furnace, as we already talked about. But it will have to be subject to the hose stream test, and it'll have to pass the F rating portion as well as the T rating portion of the test that we've already discussed. That is, if it's not going to accept any movement. That means it will be a static joint. However, if the joint is expected to tolerate any movement, it has to be tested for that movement. Remember the T rating we talked about earlier? The fire-rated joints are required to have an F rating equal to a T rating the same way that the rated assemblies are. We have a whole video on movement that you can check out if you want more information on that. It walks you through the steps to ensure that the fire stop can comply with the structural requirements of your project. It's a bit of work, but it's important, especially if you're working in an environment that will require a great deal of movement, or if you're in a hospital, because the L ratings on the walls could be critical to reducing the nosocomial infection rates. That's the idea that you go to a hospital with a broken arm and you leave with a cast and the worst stomach bug of your life. There are some hospitals, unfortunately, with horror stories resulting in loss of life because of nosocomial infection issues. So we want to make sure that if you're working in a hospital, that you're paying attention to that. Anyhow, for this discussion, we just want to say that you should make sure that if there's going to be any movement in the area, that you should confirm that the fire stop head wall detail has been tested to accommodate whatever movement is required by the building's design. As we talk about movement, there are two types. There's compression, which means the joint is getting smaller, and there's extension, which means that the joint is getting larger. When it comes to testing, the one thing we have to point out is that the joint is tested at its greatest extension, which is considered to be its most vulnerable state. And the joint is held at that extension for the duration of the 2-hour test. We'll get back to that point on movement later on in this video. So let's keep going. We're going to fire stop the head of wall of a shaft wall assembly to a flat concrete deck using fire stop sealant. We'll walk through the requirements of a few different details. You're probably familiar with details enough to know that each one is particular to a single manufacturer. Now, we don't want anyone to think that we're disparaging a particular fire stop manufacturer or even a product. So we're not going to provide you with the nomenclature of the particular details that we're discussing. But rest assured that all of the details that we're using are pulled from the UL directory. It's not our goal for you to walk away thinking that sealants are a bad solution, because that would not be accurate. No solution is a good solution unless it's installed the way it's tested, and no manufacturer is going to disagree with that statement. If you're using sealant on a project, you need to know how to review the details and compare them to the field installations to ensure that it's being done right. And that is the purpose of this coffee break video training. We'll start with this detail. It was tested for Class 2 movement, but only 8% compression and extension for a total of 16% movement. Since we're working with the U415 wall, System B, we know we have to have a 1-inch joint at the shaft liner and at the outer 2 layers, and that this system matches that requirement. But look at item 3A. It requires sealant at the head of wall at the outer 2 layers of the shaft as well as the shaft liner. Remember in our video on how to build a shaft wall, we almost skipped over this critical step in the installation. Does that happen on your project? Did they get the fire stop installed at the head of wall gap at the shaft liner, or just on the outside? That's a 1-inch gap, and some people think that because the J-track covers the gap, that you don't have to fire stop that area. But you can see here that that way of thinking is wrong. Remember, the U400 series will tell you how to build the wall, but they don't tell you how to connect that wall to the adjacent rated assemblies. For that, you need to look at the HW details, or the head of wall details. or the WW details for wall-to-wall details, such as when your gypsum wall connects to a block wall or a shear wall, but also BW details for bottom-of-wall applications, which again are going to be critical in your shaft wall assemblies. If this is the detail that's submitted for your project, you need to be sure that the sealant is installed both at the shaft liner and at the outer layer of gypsum board. But what if when you compare the fire stop details against the structural documents, you discover that 8% movement won't work for your project? Well, then you need to find a different detail. Let's look at one from a different manufacturer that allows for 25% compression and extension. We don't need to look at the CAD detail because it's going to look basically the same. Instead, I want you to look at a different section of the fire stop detail. Here you can see how we're going to compare the two fire stop head-of-wall systems. Look between the words compression and extension. In the first detail, it allows for 8% compression and extension. That means the detail allows for a total movement of 16%. That detail allows for 8% compression and 8% extension. The second detail only allows for 25% compression or 25% extension. That one little word can make a world of difference. But I don't want to stop there, because when you have a detail that allows more movement and you use sealant, you have to check for one more thing that's often in the fire stop detail but is missed by the installer. Now, this is not unique to shaft wall construction because it has more to do with the movement capacity of sealants. If you want more information on this, we'll go into greater detail in videos on movement of rated joints. But let's take a look at what the detail says. Some details will say that bond breaker is optional. Some will list it as a requirement. Well, guess what? If it's optional, then that detail will have the magic word optional. It will be critical to the performance of the fire stop detail. But again, we're trying to keep this video short and sweet. If you want to understand why, please check out the other videos on movement. There are a couple of them. That, my friends, is the end of our discussion on sealants used to fire stop head-of-wall joints at shaft assemblies. Let's recap quickly. When you use sealant at the head of wall, you need to make sure that you follow the fire stop system, which means that you need sealant at the shaft liner as well as on the outer layers of the shaft. Remember, unless you can tell me that the fire will only start from one side, you have to fire stop both sides. And unless you have a tested and listed assembly showing that, then it's not okay. Please take the time to review the movement requirements of your building and ensure that the fire stop systems are capable of accommodating whatever the movement requirements are. If you'd like help figuring that out, please check out the videos on joint movement or call us for help coordinating that. It might not be easy, but it is critical to the life safety of the building. So at this point in our series, you should understand how fire-rated walls are tested, how shaft walls are different, both in how they're built and how they're tested. That combined information should help you understand the criticality of shaft walls when we look at the life safety of a building. And this video shows you how to evaluate the head-of-wall shaft joints fire stopped with sealant. There are other videos that talk about fire stopping flat decks and more on fire stopping fluted metal decks. There's information in each of those that will relate back to things that we didn't want to repeat in these videos. So depending on what type of construction you're dealing with, please be sure to watch the other relevant videos because this is but one small piece of the puzzle. And if you're the type of person that wants to do this right, you want to get it all right, not just this. If you're the type of person who wants to get it right, then this video series was made just for you. So thank you for taking the time to watch, and we look forward to seeing you on the next video where we'll talk about spray solutions at the head-of-wall joints for fluted metal decks. After that, we'll go over a few fire stop devices that you may want to consider for your projects. Thanks again for your time, and we'll see you on your next coffee break.